When you're asked to solve for a specific variable, it means to get that variable by itself on one side of the equation. If my equation is w equals fd and I want to solve for d, it means get d by itself. So to get d by itself, I need to get rid of the f. So we're going to need to divide, since division is the opposite of multiplication, both sides of the equation by f. When I divide both sides of the equation by f, I don't know what w divided by f is. So on the left-hand side, I will get w divided by f equals, on the right-hand side, the two f's divide to 1, so I get d. This is my new equation, an equation that has d solved for. In part b, I want to solve for w. So I want to get w by itself. To get w by itself, the first thing I'll need to do is get rid of this 2l that has been added on. So we're going to subtract 2l from both sides of the equation. On the right-hand side, 2l minus 2l gives us 0l, or just the 2w. So my equation is now p minus 2l equals 2w. The next thing to do is to get rid of the 2, the coefficient of w. To get rid of the 2, I'm going to need to divide both sides by 2. That's going to cause the 2's on the right-hand side to divide out. We're going to get just w over there. And the left-hand side, I can't finish that division because I don't know what the values are for p and l. So I have just p minus 2l divided by 2 equals w. This is the new equation that has w solved for. Let's look at a few more. If I look at part C, I'm going to solve for y. So my goal is to get y by itself. The first thing we'll need to do is get rid of the 5x, since the 5x does not have any y's. So we'll subtract 5x from both sides. 5x minus 5x is 0. That leaves us with negative 8y equals 24 minus 5x. Let's copy that. And our next step is going to be to get rid of the negative 8 coefficient of y. That's multiplication, so we know that the opposite of multiplication is division. We'll have to divide both sides by negative 8. So y is going to be equal to 24 minus 5x divided by negative 8. I can leave my answer just like that, y has been solved for, or I could separate the division. We know that it's possible to distribute a multiplication across a sum, multiply both parts of the sum by the same value. It's also okay to distribute your division. You can divide both parts of a sum or difference by the same value. So to start with, it might look like this. I'm going to actually take 24 divided by negative 8 and negative 5x divided by negative 8. And we can simplify each of those. 24 divided by negative 8 is negative 3. And then for this fraction right here, notice that it has two negatives, so we're going to add. And the fraction 5/8 doesn't reduce, so I can just write it as 5/8 x. This is also considered to be simplified. So for this question, either one of those answers is fine. They're both equally simplified. It's just a matter of whether or not your division has been distributed. It's a good habit to start practicing distributing those divisions. In part because the 24/8 can be reduced, the double negative can be reduced, and also because it's going to help us write the equations of lines later on. In part D, we want to solve for t. T is inside of these parentheses with p, so what I want to do first is go ahead and distribute. So a is equal to p times 1 is p, plus p times rt is prt. And now to solve for t, because this p is not part of the t expression, we're going to subtract it from both sides. So we're going to have minus p minus p. P minus p is 0, so I have a minus p equals prt. Let's copy that. And then, because we have p and r both being multiplied by t, we're going to want to divide those off. We can divide them off together, dividing by both p and r. That's going to give us a minus p divided by pr equals t. So our equation has been solved for t. I want to solve for a in this equation. A is inside the parentheses, so it's going to be a great idea for me to go ahead and distribute here. So if I distribute, we'll get 3 times a minus 6. And we're going to want to get rid of anything that doesn't have a. And when I say get rid of, I mean, since it's a negative 6 right here, we're going to add 6 to both sides. Negative 6 plus 6 will add to 0. And also the 4b, we could get rid of that using a minus 4b. So it'll get the term that has a, 3a by itself. On the right-hand side, we'll combine those like terms. 6 plus 6 is 12, minus 4b. Let's get our a by itself. It's going to require that we divide that 3 off. Divide on both sides, of course. A is going to be equal to 12 minus 4b over 3. Or once again, we can distribute that division to write two separate fractions. If I write two fractions, notice that 12 divided by 3 is 4. And if I have minus 4 divided by 3, 4 divided by 3 is just going to be the fraction 4/3 b. So this would be the same thing as I had above, just with my division distributed. In part F, we want to take this equation and solve for y. Since it's an equation and I have an equal sign, I can multiply both sides by the common denominator to get rid of these fractions. It's going to make it a little bit easier to work with as I go through the equation. The common denominator of 4, 3, and 9 is going to be 36. So when you multiply 3/4 x times 36, you know that 4 goes into 36 9 times. 9 times 3 is 27. X minus 3 goes into 36 12 times. 12 times 2 is 24. Y equals, we know that 9 goes into 36 4 times, and 4 times negative 7 is negative 28. So now we're going to work on this equation and we're going to solve it for y. To solve for y, our next step is to get rid of the x's. We have this 27x here. We're going to want to subtract that from both sides of the equation so that we just have y on the left-hand side. After that's done, we're going to want to divide by the negative 24 to get our y by itself. And we'll work on that division. Divide both sides by negative 24. So y is equal to negative 28 minus 27x over negative 24. As in the previous example, I can leave it as one fraction or I can separate it into two fractions. However, if I leave it as one fraction, this fraction is not currently considered simplified because they all can be divided by the same number, that negative 1. So I could rewrite this as, divide everything by a negative 1. So I could rewrite this as positive 28 plus 27x divided by positive 24. That would be considered simplified. We can also simplify it into two separate fractions if we choose to distribute the divisions. Let's go ahead and look at what that would be. If I separate into two divisions, I'm going to have 28 divided by 24 plus 27x divided by 24. And each of those can be reduced. 28 and 24 can both be divided by 4. It'll give us 7/6. And 27 and 24 can both be divided by 3. It'll give us 9/8. Usually if you have a fraction with an x in it, you're going to write that x off to the side. So the simplified distributed version is going to be y equals 7/6 plus 9/8 x. In example 7, the usage of a natural gas vehicle in the U.S. was 8.3 million cubic feet in 1997 and is increasing by 1.78 million cubic feet per year. Let N be the usage of natural gas for vehicles in millions of cubic feet for the year that is 2 years since 1997. I want to find an equation, a linear model that will describe the situation. So I know that a linear model is of the form y equals mx plus b. If I know what the slope and y-intercept of the equation need to be, I can write the equation of the line. So let's look back at these values. Since it is increasing by 1.78 million cubic feet per year, that's the amount that it's changing. The rate of change is a measurement of slope. So I know that my slope, my m value, is 1.78. I also know that I have the ordered pair corresponding with 8.3 million cubic feet in 1997. 1997 is 0 years since 1997. That's going to give me the ordered pair 0, 8.3. Since I have a 0 as the x value, this ordered pair is my y-intercept, which means that my b value is 8.3. So the equation of our line will be y equals 1.78x plus 8.3. X and y aren't the variables of the problem though, so let's go ahead and change those. The independent variable is t for years since 1997, and the dependent variable will be n for natural gas usage. In part B, we want to solve the equation we found in part A for t. So we're going to take this equation, get t by itself. To get t by itself, we're going to have to subtract the 8.3 from both sides of the equation. On the right-hand side, 8.3 minus 8.3 gives us 0. On the left-hand side, we have our n minus 8.3. And then to get the t by itself, we're going to have to divide both sides by the 1.78. Alright, let's copy that. We know that 1.78 divided by 1.78 is 1, so I just have t on that side. And the other side does not simplify, but it can be rewritten using the distributive property as n divided by 1.78 minus 8.3 divided by 1.78. Let's simplify each of these smaller fractions. Remember that the coefficient of n right here would have been 1, so I'm going to divide 1 by 1.78 to get the new coefficient of n. So 1 divided by 1.78 gives us about 0.562 n, if I round to the nearest thousands place, minus 8.3 divided by 1.78 gives us about 4.663, if I round to the thousandth place, equals t. So this is our equation that has been simplified using the distributive property. And like I said before, we're often going to want to simplify our equation like this when I'm working with linear equations. In part C, I want to predict in which year the uses of natural gas will be 31 million cubic feet. So I'm looking at having an n value here of 31. We're going to go ahead and use the equation that we found in part B, plug our 31 in for n, and to find our t value. This is one of the reasons it's important to make sure that we use at least 3 decimal places of accuracy in the equation so that my answer is going to have some accuracy in it as well. Let's plug our 31 in for n. We'll take 0.562 times 31. That'll give you 17.422 minus the 4.663 equals t. So if you do the subtraction, you're going to get 12.759 equals t. Now we need to interpret what that means. The t value is the number of years since our starting year. Remember that our starting year was the year 1997. So we'll take our 12.759, add it to 1997, and we'll come up with 2009.759, which means that this is going to happen in the year 2009, sometime near the end because of the 0.759, but the year that this will happen is during 2009. So we predict that the uses of natural gas for vehicles will be 31 million cubic feet in the year 2009.